Aloha, Richard Halverson here. This is ICS321, and today is February 11th, spring 2021. And so we're in like the 5th week. Let me share my screen. And okay, so we are like, in this week. So we are doing, we're covering chapter 3. We covered like sections 3.1 to 3.5 last time. We're going to cover the rest of them this time. And so okay, now so just to review here, there is I don't have the, do I post the, I guess I don't have the, I've actually created a playlist for the class, but I haven't posted it up. I have to post the link up here, so it doesn't make any sense for me to tell you about it because then you just won't be able to find it when you come to it. But anyway, all of these videos are in a playlist, so it's I think so it's in this class I do go over, let's see, I guess mainly what I'm going over is the textbook. And so a lot of the actual assignments where you actually have to, do stuff step by step, those videos are actually embedded in the assignments themselves. So I guess it's not quite super important that you follow along with each video in this class, because the important stuff is like in the assignment. For example, you just look here and you read, and there's a video here and shows you how to do it. All right, so so the last video, this was the last video we did, which is, you can also go to resources and go to I shouldn't, okay, 2021 videos, and they're all here. So we've done 1 through 5 and chapter 3. We've done chapter 3. And so if you click on this video right here, you can open it up. And what I do is I go all the way to the end until I don't see any more of the textbook, till just the very end of the textbook. And that's about here. And so we see 3.4, which is talking about dependent and independent entities. I don't think we actually really talked too much about that. So that's kind of about where I'm going to start. Here's the textbook. I notice I'm able to click on this report, and I see that you guys are coming along. You're keeping up. You're following along. I'm talking about. We're in chapter 3 right now. So this is the percentage of completion for the class, and that's pretty good because there's not real strict deadlines, but you guys are keeping up, which is a good thing to do. And this is easy. This is just, you just go along and click around, and if you don't feel like thinking too hard, you can just click and see the answer, and that's what it is. Of course, that makes sense. And so anyway, we finished up chapter 3, section 3, which has to do with the cardinality, which is the minimum and the maximums for these relations. There's one-to-one, one-to-many relationships between entities in a database. Okay, so that's what we talked about in section 3.3. 3.4, we start to talk about dependent and independent and dependent entities. Okay, so this is not the same. This dependency is not the same as dependency in databases. We're not talking about functional dependencies. We're talking about these existence dependencies. Okay, and so an entity depends on entity A depends on entity B if instances of A can exist only when they're in relation to an instance of B. So there's this master entity, like you can't have you can't have an apartment without an apartment building. Okay, so there's the master entity would be the apartment building, and then inside the apartment building you have these apartments, and so the apartments are dependent entities. If you abolish the building, you abolish all of the entities that depended on the master entity. Okay, and so these are kind of expressed like this, like, okay, so you have projects, tasks, and subtasks, and so it's expressed using these arrows, these upward arrows. A passport cannot exist without a person or a country. If either of the person or the country goes out of existence, the passport doesn't mean anything anymore in most cases, and so on. So a booking has to have a flight. A booking cannot exist without the flight and without the passenger. All right, so this is a nice exercise to do. How often is independent and dependent? I think is this always master? Oh, a master entity can depend on another entity. Okay, so there's this this is the first time we talk about dependent relationship. A master entity and independent. Where do we talk about dependent and independent? Okay, an independent entity can exist on its own. A project can exist on its own. A master entity. Okay, is this? Oh, okay, a task. A task is like a master entity to subtasks, and that's why you can have. That's why this is sometimes. Entity relationship model and diagram conventions. Okay, so there's all different kinds of conventions for expressing entity relationships. Okay, and that's what this talks about here. There's different terms for the same thing. Like independent entities are considered strong entities, and dependent entities in some conventions are called weak entities. A group of related entities is called a subject area, and there's the way some ER diagrams may depict relationship names with names inside of a diamond, or some with a diamond. Some depict dependency relationships with a diamond rather than an arrowhead, and so on. Cardinality. I happen to like crow's feet, but some use bars and circles and so on. Some use other forms of expressing the one-to-many and the one-to-one and so on. Several model and diagram conventions. There's the unified modeling language, which I see the most of, and I don't so much these other conventions. Here's the cloud information model. Here's an example of we can see relationships between these. We have a shipment, and a shipment has to have a product, and this is a dependency thing where product depends on the it doesn't exist without the shipment. The shipment product doesn't exist, but the entity rectangles have round corners. Okay, the entity rectangles have round corners, The cardinality is depicted by crow's feet notation. Dependency relationships are depicted by diamonds. Okay, so these are the dependency relationships. These all depend on the shipment. And these are crow's feet here where this is like one to many. And this double bar means, I think you got to have at least one or something. I can't remember what the double bar means, but it has to do with whether there has to be at least one or there can be zero. Okay, this is zero to many. All right. Is this described here? Okay. Anyway, so that's what. So you want to make sure you nail that down. I don't see it's describing here. It's described specifically here. I think it's just this is just showing as an example.
I think it means one and only one.
Pardon?
I think it means one and only one.
Yeah. The double bar. Yeah. Okay. One and only one. Okay. If it's yes. Okay. And this is zero to many. This one here.
Right.
Yeah. Yeah. Okay. I remember now. I'm trying to remember now. Right. You're right. This is all coming back to me now. Yeah,
I just went through this recently, so that's the reason I know.
Good. Yeah, I in this particular class, I did teach this notation, but then I dropped it a couple years ago, and then now with this textbook, this is the first time I've actually gone through the chapters of these textbook of this new textbook. In the past, it's been sort of I didn't weigh it as highly, but yeah, I do prefer this. This does make the most sense, but whenever you see it, whenever you haven't seen it for a while, then you see it again, you got to remember what all these little things mean.
Yeah.
Anyway, great. Okay, so that's good. Okay, so here, okay, so now we're getting into database design, and the database designer distinguishes independent and dependent. Does that after figuring out what the relationships and attributes and cardinality is and so on. And then for each dependent entity, the dependency relationship is defined and so on. So first you identify the independent and dependent entities, determine the dependency relationships, and then you document it. It depends. If it's large and you're working on a team, you want to make sure you do this part. So here we're imagining creating a database, and we're supposed to say what each of these is. Let's see what this is. So a school district, is it? We're supposed to identify the dependency, select the correct dependency relationship for each entity. So a school district can exist on its own. Okay. Maintains a database with information about school districts in the state. Each school district has a school board. A person gains a seat on the school board by winning a local election. If a school district is eliminated, with students getting assigned to a neighboring district. Okay, so a school district is independent. A school board depends on a school district, and a person is independent. Okay, so anyway, so then and that's then if you think about what happens if you abolish these things, the person still will exist, but just a dependency will no longer exist because the thing that the thing that is being depended upon is eliminated. Right. So you can continue with these. European Football League. So a player is going to be a player is independent. The player will always exist. A team I guess, will probably always exist, but a contract depends on the player on the team, obviously. So, okay, so super types and subtypes. We can kind of see how this relates to entities. An entity type is a set of entity instances, and this is a set of entity instances, and a subtype entity is a subtype of another one. So you know, a manager is a subtype of an employee. You know, you have to be an employee, but then some employees are managers. So the super type is the employee, and the subtype is the manager. And so here, you know, we have a super type is a vehicle, but we have different subtypes, and we have electric vehicles, and we have gasoline vehicles. And so there's certain you know, attributes, properties, or whatever that can belong to either the subtype or the super type. If it belongs to the super type, it also belongs to the subtype. It's a character. It's an attribute of the subtype also. And so there's this concept called ISA, you know, and so we have a subtype is a supertype. So that's what that means. So this is a way of expressing if this is a subtype of this supertype. All right, so so here, okay, so and now this is a common database thing. This kind of relates to normalization, okay, in some ways. Where you have a database, or you're creating a database, or there's an existing system of storing data, which can be, you know, spreadsheets and, you know, databases that are not connected and so on, and you want to create one. And so we have let's say we have students, and we have faculty, and we have administrators, and these are in different places, and we you know, examine this, and we find that there are common fields. You know, there are common fields, and so what you can do then is you can define a super type that's got all the common fields, and then you define subtypes within the super type that you know, like this, and then the you know, the fields can be so all the fields on the left here find a place on the right, but the place is either in the supertype or the subtype. So there are these mutually exclusive things here. Although, yeah. All right. So optional attributes move to new subtype entity. Required attributes remain in the supertype entity. So when a subtype is created, there can be optional attributes, and let's see, and then required. Well, this is just explaining distinguishing between attributes in the supertype and attributes in the subtype. Similar attributes and optional attributes. Which entity does grade point average belong to? Well, I guess it belongs to the student, not the person, the student. which entity does telephone number belong to? It belongs to a student and a faculty and an administrator, which are subtypes of the supertype person. They can all have phone numbers, so I would guess it's this one. And an employment status would only be, can it belong to more than one? Faculties of administrators or salaried, which we call employment status. So that's just administrative staff. So I guess that's just this one. And then we can have these mutually exclusive subtype entities. You know, you have cards for buying, you know, a credit card or whatever to buy. They can be credit cards or debit cards or gift cards or whatever. There can be different brands. It's going to be like only one of these and only one of these, but any combination kind of thing. All right, so so now we're kind of moving into how we take, you know, after we've analyzed everything about all of the different entities in our new database, then we figure out how we're actually going to implement it using you know, some kind of SQL database. So after entities, relationships, attributes, you know, after all these things are determined, then the database designer looks for supertype and subtype entities, and similar entities and optional attributes suggest new supertype and subtype entities, which is good. Mutual exclusion subtypes are grouped into partitions and so on. Okay, so you do all that, and then this describes, if you understand how to do that. Now what's this one? A library provides different kinds of resources. Each book has a call number. Each resource has a title and a publisher name. Okay, let's just start and see what happens. Select the correct description for each attribute. Title is an attribute of a subtype entity. Title each resource has a title and a publisher name. So this must be the resource. The library provides different kinds of resources. Well, resources would be the supertype. Each resource has a title. So title is an attribute of a supertype entity. And then listening time would be an attribute of a subtype entity, because listening time only refers to an audiobook. Attribute of a subtype entity, I think. Okay, so that's all there was. All right, so here, implementing entities, here's where we get into databases or tables and defining primary keys and figuring out what the foreign keys are, and eventually what the foreign key constraints are, you know, for deletions and updates. So the first step is each entity becomes a table and each attribute becomes a column. Tables and columns are reviewed and revised in subsequent logical design steps. And so tables and columns are specified, primary keys are selected. You know, as you know, primary keys need to be unique, not null. So primary keys correspond to unique and required attributes, always. And in addition, primary keys should be stable. You know, they shouldn't change. If they can change it, you know, that can cause problems. You know, even something like, well, I know an email address is used commonly for a key, for a primary key of people, or for a login, for example. But for login, you know, it's okay, but but really it's the login. The trouble is with an email address is that it can change. You know, you want it to be something where no one's ever going to want to change it because they don't care at all of what it is. You know, so that's why just a number, just an integer, starting with 1, number 1, an integer, or maybe starting with, let's say you're gonna, you know, let's say you want your primary keys all to be the same length. So then you figure out how many you're going to possibly have, and if it's 1,000,000, that's 6 digits. So maybe go with 8 digits. 1,000,000 is 7 digits. So maybe go with 10 digits. Go with a 10-digit number, or maybe it's an 8-digit number is fine. And then you can start with 10 million. Start with the value 10 million, or 10,000,001, and then increment up from there. And then no one's going to care, or you know, no one is going to care what that key is, and it can stay that way forever. That's the best kind of key. You're guaranteed unique. All right, so this describes that, basically meaningless. So selecting primary key. So you go through this, make sure you understand that. Implementing independent entities. So an independent entity becomes an independent table, and so it has a primary key. You know, you want some sort of artificial type key, and refer to the vehicle independent entity. Correct answers may depend on business rules. Okay, so we're supposed to say, select this. Okay, dealer invoice number is a good primary key. This is for a vehicle. Well, this is for an entire vehicle. Okay, no, that's crazy. Okay, no, false. Because to the right of the zero is this. Oh, yeah, it's 0. The 0 to the right of the dealer number indicates the dealer invoice number is optional. Okay, so that's why. That's what's up. Okay. License plate number is a good primary key. No, well, it's not, because license plates can be stolen and changed, and so you have a vehicle there, and somewhere along the line, its license plate number changes, and so goes to another town, or so, goes to another state or something. Vehicle identification number, yes, that's a good primary key, and in fact, that's independent. So that's a really good primary key. A composite of the manufacturer's name, the make code, and the year number. I don't think so, because make code is yeah, these so anyway, I'm curious what the answer is. I think the answer may be false, but is it? Well, many vehicles share the same. Yeah, okay. All three of them. There's no serial number. If there were a serial number, that some sort of thing like that, that would be add that in there too. And new artificial key is a good primary key. Yes, it's always good. Okay. Implementing subtype entities, there you usually have some sort of composite primary key. Subtype entity becomes a subtype table, which is implemented. The primary key is identical to the supertype primary key, and the primary key is also a foreign. The primary key is also a foreign key that refers to the supertype primary key. So here you have a mileage plan number. Well, anyway, so the mileage plan numbers got this, which is okay, the primary key of a subtype table. So this is a passenger. Passenger has a mileage plan number. The subtype's primary is identical to the supertype's primary. The primary key of the subtype is also the foreign key referencing the supertype. Okay, so A dependent entity becomes a dependent table. Primary key is usually composite. It includes the foreign key that references the master key and another column which makes the composite primary key unique. So you know, you have a project's got a bunch of tasks. If you want to talk about just a task, you're going to need to identify the project that the task is a part of. You know, it's kind of like a restaurant. You have a check, you know, that's got all the stuff that at the table, you know, all the stuff everybody ordered. And so, you know, the check, you know, there's an order, an item that's been ordered, and that's going to be, you know, this is the weak entity or the dependency relationship that we're talking about before. So it's the composite. So it's usually a composite key where part of the key is the primary key of the master. So here, for example, with the booking, it's again, it doesn't exist without both these, and so the good primary key for all the bookings would be a composite key that's got the flight and the passenger number in there. All right, so here's another example with airports and runways. You have to have an airport before you can have a runway. And so here for database design, implementing entities, the implementing entity step creates an initial table and specifies primary keys. And if there's no suitable primary key, you usually use an artificial primary key as some sort of just an incrementing integer, or maybe you do that anyway. The design is augmented as the relationships and attributes are implemented. So some decisions in the final step are affected by the database design. So first we implement the independent entities as tables, and we create the keys for them, if artificial ones if necessary. Then we implement the subtype entities as tables. That may involve pulling out data from, you know, the super type. Implement the dependent entities as tables, and specify the cascade and restrict actions for the dependency relationships. You know, if a super type is deleted, if somebody attempts to delete a super type, do you want to just go ahead and delete subtypes that depend on it, or do you want to you know, throw an exception and tell the user that that's an illegal operation? If you want to delete this super type, you gotta go delete these. Got to take care of these subtypes first. So here's assume the following rules. Let's just see what this is. Assume the following rules. Each product has a description. No two products have the same description. The product's description includes information such as the source and the price. Occasionally, the product marketing team corrects errors or adds information to the product description. The product description usually consists of a few sentences. Which of the following properties does the description attribute have? Is it unique? Yeah, it looks like it's unique because no two products have the same description. Is it required? I don't know if it's required or not. Each product has a description? Yes, must be required. Is it stable? No, it's not stable because it can be edited. It can be edited. Edit. Past tense of edit. Simple. Is it simple? No, it's pretty complicated. Is it meaningless? No, it's not meaningless. It's very important. So let's see if this is the answer. Oh, yes, unique and required. All right, so you can go ahead and assume the following rules. So what is the best primary key for the department table? Departments, divisions. Division may have many departments. Each department is in one division. There's a department, okay. Primary key of a division is division number. Each department has a required department name and department code. Department code. Department name is unique across all departments. Department code is unique within a division, but may be repeated for departments in different divisions. What's the best primary key for the department table? Well, this is a good one. Division number with department code. Not department code, because department code, it just says right here, department code is unique within a division, but may be repeated for departments in different divisions. So that's not good. Department name would work because it's unique across all departments, but department names can change. People have opinions about department names. Some people might prefer a different name for their department. So that's not a good primary key, because primary key people should not have any opinion about what it ends up being, although it is unique. And then a division number and department name, well, that's unique also. And that's in fact, it's a super, that'd be like a super key, because you don't need the division number. So anyway, I would say this is the answer. All right, implementing relationships. So here is where we have to decide things like implementing many-to-one relationships. That says where the foreign key goes. If it's an many one or one-to-many relationship becomes a foreign key. Okay, so foreign key goes in the table on the many side of the relationship. So if you have a table of parents, no, well, it's if you have a table of divisions and you have a table of departments, you know, let's take this last example here. You have divisions, and departments. You have divisions and departments, and a department belongs to a division. There can be a department belongs to one division. Okay, so what they're saying is that there can be many departments in a division. So the many side is where the foreign key goes. So you have the maintenance department, and in the maintenance department, then the record with the maintenance department has the division that it belongs to, because there can be many departments that have the same division, they all belong to the same division. So you would not put the foreign key in the division table, because it's many. You could put there's not you would have to have as many fields as the maximum number of departments that you'd have, and it'd be a mess and everything. So a foreign key refers to the primary key on the one side. So we're talking about one to many, many to one, or one to many. And so the primary key of the one side, and that becomes the foreign key on the many side. The foreign key name is the primary key name with the optional prefix. The foreign key name is the primary key name with the optional prefix. The prefix is derived from the relationship name and clarifies the meaning of the foreign key. All right, well, you can read that sentence, that couple sentences over again a few times to make sure you understand it. But here, for example, we have a flight arrives at many to one. This is you have an airport, you got many flights arriving at the airport. So there's many flights, one airport. So it's the flight side that's got to have the airport code, and the airport code is the primary key of this table here. like this. See, okay, so an aircraft is assigned to a flight number. Okay, so we can have a single aircraft, a single plane, can actually be many flight numbers. You know, plane flies from Oahu to Maui, it's got a particular flight number, and then that plane turns around and flies from Maui back to Honolulu. Honolulu to Maui, Maui to Honolulu, it's a different flight number. Okay, so there you would have in the many side, you would have the aircraft code. So the aircraft code would go in there. Implementing one-to-one relationships. The foreign key can go in the table on either side. Usually the foreign key is placed in the table with fewer rows to minimize the number of null values. Foreign key refers to the primary key of the opposite side of the relationship. Okay, so you've got these addresses and airports, I guess. So you can have, I mean, you can do whatever you want here, really. But every airport has an address, but not every address has an airport. So you can think about. So you would probably have the address ID in the airport record, because obviously, obviously you do that. All right. Implementing many-to-many relationships. Okay, so there you actually have to have another table. Okay, it's kind of like supplier parts. Okay, you've got suppliers, you get parts, many-to-many. Suppliers can make many parts. Parts can be made by many suppliers, and so are shipped. In the supplier parts, it's shipments. And so you have this second table where the primary key is a composite. A primary key is a composite of the two foreign keys that are the primary keys of the supplier table and of the parts table. So so if it's one-to-one, where you put the primary key of the other entity can go in either side. If it's one-to-many, the foreign key goes into the many side, and the foreign key is the primary key of the one side. And then for many-to-many, you have to have a table in the middle. They can have that can have as many combinations of the primary keys of each of the sides of each of the sides. Implementing relationships. So here, a student has let's see what this looks like. How far are we implementing attributes? This might be the end. Implementing attributes. Oh, and then normalization. Okay, right. So implementing these. See, I was going to do this challenge activity here. Yeah, this one. Start. What is this? In which table is the foreign key placed? Okay, this is a one-to-many. So the foreign key will be placed on the many side. So it'd be placed on the student side. A student is assigned a dormitory. So it would be on the student side. What is the name of the new foreign key? Well, is this some sort of convention now, or no? It's this. Yes, it's this. Are nulls allowed in the foreign key column? I think so. If a student is not assigned a dormitory, look, there's zeros here. There's a zero here. So there. Yes. Let's see what the answer is. Very good. The second one is, in which table would the foreign key usually be placed? Well, this is one-to-one. This is where a seat, passenger. Jeez, I think it really matters. In which table would the foreign key be placed? The seat, I guess in the seat. What is the name of the new foreign key? Well, passenger ID? Are nulls allowed? Can a seat? Yeah, sure, there's zeros there. Yes, the minimum on seat side is 0. Yeah. Minimum on passenger side is 0. Yes. Minimum on seat side is 1. Minimum on passenger side is okay. Well, passenger's got to be at least 1 because you can't have a passenger without a seat, because then the person's not a passenger. Okay. Passenger has to have a seat to be a the person has to have a seat to be a passenger. So person has to have a seat. Person has to have a seat to be a passenger. So maybe then there's always going to be a seat here, but there could be no. Okay, so I guess maybe we want this to be passenger. What is the name of the foreign key? Seat. And are nulls allowed in the foreign key column? I guess no. The minimum on the seat side are nulls allowed on the foreign key column. The foreign key is seat ID. No, the minimum. Yeah. Okay. This is my answer. No. Each incorrect answer is highlighted. Oh, each incorrect answer is highlighted. That means each one of these is okay. Well, if you're going to get one wrong, if you get one wrong, you're going to get all the rest of them wrong. Okay, so what does it say? The foreign key usually goes in the table with fewer rows. The seat table will usually have fewer rows than the passenger table. The seat table will usually have fewer rows than the passenger table. So the foreign key goes on the seat table. The seat table will have fewer. Well, how can you be a passenger without a seat? Okay, all right. So my understanding of the definition of a passenger was wrong, I guess. So anyway, so if you can have passengers without seats, nulls are allowed in the passenger ID column of the seat table.
I guess they're talking about overbooking. You could have passengers without seats if they overbook, I guess.
Yeah. Nulls are, because the minimum on the passenger side is 0. So nulls are allowed in the passenger ID column of the seat table. Okay, yeah, wow, that's weird. Well, I guess what you do is you need to, I got the first one right. I guess I just do it again. And you just do, okay, now this is easier. You can't have a driver's license without a person, right? Okay, so the driver's license should have the foreign key in it. You can certainly have persons without driver's licenses. So the driver's license should have the foreign key. So this one's easy. I hope this one's easy. Pick the name of the foreign key. Person ID. Are nulls allowed in the foreign key column? I would think not. See, it's not, no, the minimum on the person's side is 1. Okay, or maybe it's this. Is this right? Okay, no, the minimum on the person's side is wrong. So the answer is nulls are not allowed in the person ID column of the driver's license table because the minimum on the person side is 1. See, I don't have that straight in my brain what that means. The minimum on the person side is 1. Because the minimum on the person side is 1. That's this. And is that the one in parentheses? Yes, it must be. So that means that a driver's license has to have a 1. So nulls are not allowed in the person ID column of the driver's license table. That's what it's true. No, it's not allowed there because the minimum on the person side is 1. Okay, so they're just saying that on this side, it's 1. So this is the person side. And what this is this says something about what is populated in the foreign key field here, but so that's what I was thinking. So anyway, you can try it again. Okay, you out there in student land can try it again. Okay, it's 423. So let's we should be able to finish this up. Okay, implementing attributes, implementing plural attributes. Attributes can be singular or plural. Each entity instance has at most 1 singular attribute instance. Each entity instance can have many plural attribute instances. I'm not sure what that means. I see. Okay. So the implementation, entities become tables, attributes become columns, singular attributes remain in the initial table, but plural attributes move to a new table. Okay, that makes sense. A new table contains the plural attribute and a foreign key referencing the initial table. So, so this is, okay, so if you have like many meals, if a flight can have many different meals, so you have a separate table that's got the meals, and it's got the meal types, and in the meal type tables, you have the flight number that it refers to. Of course, you could have many meal, or a meal can go on many flights. You know, a flight can have many meals. You could have a relationship like that too. I don't know if they're referring to that here, but anyway, so this is plural types, so implementing attribute types. Okay, here we're starting to get into the field types, char, varchar, and so on. Those are saying it's going to be characters with a maximum of 4 characters for the airport code, a maximum of 30 characters for the airport name, and so on. It's defining the attributes, defining the storage type, the variable type of the attributes. This is implementing attribute cardinality. All right. Yeah. I see. Okay. When to use not null? When to use unique? And normalization, this is a lot like what was covered in the last section of the last chapter, which was normal forms. This is normalization, and this is taking a table that is not in Boyce Cod and converting it into tables that are Boyce Cod. And it talks about here, and this is exactly what you're doing in assignment 2. It's exactly what you're doing in this assignment, normalization by projection. So you got these big tables in first normal form, and by using projections, you convert them into the highest normal forms. And there's a video here which shows you how to do it. But anyway, that's what this is. And denormalization. Okay, they talk about denormalization. Now sometimes it's a good idea to have a table around that's created already that is actually, you know, not Boyce Cod. It's so there's redundancy in there, and you may do something like that for efficiency reasons or to speed things up. You know, maybe, and it would have to be where it really does take a long time to do that join, and there are cases where that's the case, where it takes a long time to do the join. And also, if it's okay if you're working off a static copy, or if that's something you should do is work off a static copy, where something gets updated, you know, every night or something, and you want the data to stay the same throughout the next day until the next night, then that's a very good time to do this, because then you can update the base tables, you know, the BCNF tables that and then you do a join denormalization, save it into a separate daily table that's not in BCNF, and you may do that for performance. All right, so that's it for chapter 3. I don't know how helpful this little lecture was, but I hope it helped. And next time we are, let's see what's on the agenda for next week. It's gonna be this week. Oh, yeah, that's right. There's a holiday on Monday, but so then we're gonna start getting into chapter 4, where Zybooks talks about structured query language, and this assignment 2 is you can start working on assignment 2 next week also. All right. So any questions?
Nope.
Okay. So I will see you next week.
Okay, sounds good. Thanks.
Yeah, have a good week.